Hey everybody, my name is Liam Taylor. I'm with EXA Infrastructure. Working? Yeah, great. So you've probably seen the postcards on the tables inside that my colleague Sebastian left over the place. EXA network, you may be familiar with it. We've got a fibre network all over Europe, and then we've got a pretty developed submarine network across the Atlantic as well. A lot of different pops. I won't go into the numbers. You can grab yourself a postcard if you're really interested in it. So what I'm here to talk to you about is MOFN and shared spectrum, where they fit in. So traditionally, what we had with services is that we would have our wavelength services where people would access 10 gigs, 100 gigs, 400 gigs. Now you're starting to see maybe 800 gigs, where as a customer, really all you have to worry about is your demarcation point and maybe a cross connect. And your vendor will manage everything in the middle, be it the actual physical sites, the DWDM equipment, and any kind of network plan that needs to happen. There are some big notes with that, so obviously it's lower bandwidth and then it's higher cost per gigabit, but minimal obligations and fairly straightforward as a customer. If you just say, I want capacity from A to B, and if you need more, you can generally go to your vendor and say, I want additional wavelength between those 2 points. All the way down the other end of the spectrum, you would have dark fiber, where you would have to manage, and depending on how much you wanted to take on yourself, if you wanted to go ahead and build a duct yourself, you'd have to worry about a lot more of this yourself, a lot more of a headache. But in general, you'd have a dark fiber provider who would manage the fiber. You'd have a colocation provider who might manage any ILEAs you need. And then as a customer, you just have to worry about maintaining an optical level and an electrical level, the actual equipment. Some big advantages with that, obviously, we get a high level of bandwidth and we get a high level of complexity, but it does come with more manpower requirements. We're probably going to need field teams to support that, and we're probably going to need a dedicated transmission team to make sure everything's running nice and sweet. Depending on where you are as well, that can come with licensing requirements. In some markets, I know we're currently doing a build in Turkey, and unless you are licensed as a telecom operator, you cannot build a DWDM network in that location. But you do get the big advantage in that whatever you want to deploy, it's down to you. You have the big call. So in the middle there, we have the gap. So it's quite a leap from individual wavelength services to managing your dark fiber. And really that's where shared spectrum and MOFN come into play. So shared spectrum is just enabling you to get a portion of an existing network. We'll generally measure it in gigahertz or terahertz. Sometimes you'll see percentage of spectrum. I don't particularly like that, but that's terrestrially. We know this is the C band, and maybe if we have L band as well, a percentage of the spectrum is a guaranteed thing. On submarine, the repeaters can have different things, but that's a personal gripe. But basically, as a client, you just have to bring your own transponders, maybe a WSS, depending on the type of shared spectrum. The vendor will assign you physical spectrum, and you can do this on a terrestrial level or on a submarine level. It's gotten quite popular on submarine in the last couple of years, mainly because submarine pairs aren't very common. They can be very expensive, and you need a lot of bandwidth requirements to require a full pair. So if you can get access to a quarter of a pair, it can be ideal. So traditionally, what we have with alien waves, I mean, shared spectrum has kind of been around for quite a long time. What we'd have is alien waves, or some people call them foreign waves. And that's literally just me as a vendor. I'll turn around and say, okay, you've got this frequency, plug into this port, and I'll tie it into my MUX, and you'll just be able to send it from A to B. It's cheap to implement, and there's not much in terms of hardware requirement, but it does have problems. Me as a vendor, it scares me because I don't have any control on the power you're sending in. Now, this will be on an old network before WSS has come in. Modern networks with a WSS, I can control the power a little bit more, so that's gone down a little bit. But this model has kind of fallen out of favor, but it is very cheap to implement, so you are still seeing it in some places. There is a bit of a drawback as well, though, in that cross-connects can get very expensive depending on the market you're in. You need one cross-connect per wave. Moving on to the more modern implementations, what we have is one implementation is managed spectrum, whereby you will get a percentage of spectrum, let's say 25%, and then we will work together as a vendor and as a customer, and we'll agree on what your spectral plan is going to be. And I'll say, okay, you have channel 1, channel 2, channel 3 on these frequencies with these baud rates, and they'll fit into the spectrum as required. It does come with a lot of advantages. As a vendor, I'm happy because there is full power control. You'll have a WSS that will monitor the power levels going in and out. If you have a fiber cut, and certainly on a submarine, you might be able to substitute an ASE I'm happy. You're not going to cause outages on other people's bandwidth. That's great. And we're down to one single cross connect. Does require a bit more coordination with the vendor than would unmanaged spectrum, which we'll get into now, because we need to agree on a channel plan. And if you ever want to make any changes to that channel plan, we need to coordinate. The optimum really for, or at least in my opinion, for shared spectrum will be unmanaged spectrum. And that's literally where you'll be assigned a block. You'll be assigned a block, and as long as you meet the power constraints in there, you send a certain amount of optical power with a certain spectral density, I'm happy, and I'll just transmit it through on the other side. So if you ever want to add channels, remove channels, change your grouping, make channels tighter to fit more traffic in, you have the full freedom to do that. And as a vendor, we're maintaining power control, so I am quite happy. Certainly, if I'm getting a spectrum share on another provider's cable, this is what I look for as we unmanaged spectrum, because it gives us full control. But unmanaged spectrum and managed spectrum do require a greater degree of knowledge. You will want to know about things like grouping and stuff to really maximize the amount you're getting out of your asset. How much spectrum do we need? Well, that's a bit of a chicken and egg problem. In order to know, let's say we want to send traffic from Zurich to Prague, you need to know what the fiber is like, how many amplifier sites are in between it, how many ROADMs are you going to be going through, what transponder generation are you going to use. So really that's going to need to be a conversation between the vendor and the customer to establish, okay, well, what generation of hardware are you using? And then based on that, I mean, distance is the primary factor, but there's a lot of other factors that will go into it. Based on that, you'll be able to say, okay, well, you should get 600 gig per channel. You're going to use 100 gigahertz channels. You want to get a certain amount of traffic. From that, we can determine this is the amount of spectrum that you need. So it's not quite as straightforward as I just want this amount of spectrum. It needs to be a kind of a conversation on how much do I need, and then what will I actually need to get out of it. So next thing then will be talking about MOFN. MOFN is Managed Optical Fiber Network. You often see it as just MFN, dropping the O, but it's the same thing. And what this really is DWDM as a service. It does get around some of the problems that we'll encounter with trying to build out a network. I mean, it can be quite easy for us if we're talking about a metro level, where we just have two sites that are quite close together. Fairly straightforward. Even if you have to throw an amplifier on, it can be quite easy to do. But once you start extending beyond a metro level and you're talking about multiple ILAs, the complexity can get a lot higher. So it can be much easier for us to scale if we can just hand off all of these things onto our provider. And that's really what MOFN's all about. So with it, we can get around the time to build. We don't need to, acquire multiple ducts, multiple dark fibers, and multiple sites, multiple ILAs. We can just go to our vendor and say, hey, I need you to build me a network from A to B, and we can discuss everything in terms of how much capacity you need, whether you need just one pair or multiple pairs. The biggest thing really is that you then also don't need to have all of those staff as well. You don't need to have all those field techs to install all those sites in multiple different regions, multiple different countries. So when it comes to MOFN, it's not quite as standard as there being just one product. What you have is, and this will be a standard offering that we would offer for MOFN, and it's almost cookie cutter. So the biggest draw would really be down to the physical infrastructure provision, where you're looking at what dark fiber is there. We can discuss what dark fiber is there, what build needs to be done as part of the project. Project management teams that will be able to handle that, they'll be used to working in market, and they'll be able to work and set realistic provisions. There can also be big advantages. I know other people have mentioned lead times getting kind of excessive. Vendors will change your price book and will change your lead time based on your spend. And if you're going to a provider who has a bigger spend, and they will get lower lead times, and they will get a better price book. And with MOFN, you can often work with your vendor to get that better price book and better lead time as part of the project. Another thing that's not necessarily mentioned on the slides there, but is a big draw. So with all of this together, it kind of ties in and fills in our gap. So you can look at this now as a full portfolio where we have wavelength. We're looking at kind of minimum amount of ownership from a client perspective, and then stepping up into spectrum, into MOFN, into dark fiber, the more ownership you want to take over. And then as a vendor, it really changes based on which type of product you have in the middle. So I hope that's answered everything for you guys on spectrum sharing and MOFN. If you have any questions, please go ahead. I've got 5 minutes left. I might shoot through it a little bit too quickly.
Any questions?
Excuse me.
Hi, this is Benjamin from Banque Pictet. Thank you for your presentation. I was wondering if there is any kind of waste on a link if you do shared spectrum on it. Like basically, if you have like a 100 gig a link, and if you do shared spectrum on it, like do you manage to get the sum of all the shared spectrum to 100 G?
You should implement guard bands, and generally that will be part of the agreement. Would be that if you're assigned 1 terahertz, it would be assumed that inside that 1 terahertz you'll have, it's quite small, might only be 6.25 gigahertz on either side, but that would be pretty standard. So you'll have a slight reduction, but not a huge amount. I mean, most of the time when you think about a 100 gigahertz channel, it's not actually 100 gigahertz. That channel is probably actually 87.5 in there. So that guard band's nearly already in there. So yes, you can get a slight reduction, but it tends to not be significant.
Thank you.
Maybe yes, no. Okay, I think there's no more questions. Thank you very much. Yeah.